Next, solution of differential equation. The solution is any function defined on the interval I that possesses at least n derivatives that are continuous on I, which when substituted into an n-order differential equation, reduce the equation to an identity. So the solution of differential equations will be in some form of the function that satisfy the differential equation provided. The interval I that contains the solution is called the interval of definition, or the interval of existence, or the interval of validity, or the domain of the solution, which we are more familiar with. A solution of differential equation is identically zero. We call it a trivial solution. A graph of the solution of the differential equation is called a solution curve. In some texts, the solution of differential equations is called an integral of equation because for the first derivative, we derive the solution by doing the antiderivative or integrating. The graph is also called an integral curve. A solution of the n-order differential equation is called the n-parameter family of solutions. Most of the time, we omit the term n-parameter. We just call the family of solutions. And you can see the parameter C1 and C2 for this example. Also, we call this as a general solution. A solution of differential equations that is free of arbitrary parameters is called a particular solution. So in this case, if we use the same example, C1 and C2 will be replaced with some real numbers based on the initial condition provided. The last case, a singular solution. Singular solution is an extra solution that cannot be obtained by specializing any of the parameters in the family of solutions. Other way we call it the solution make it undefined. Next example. Verify that the indicated function is a solution of the given differential equation and give an interval I of definition of each solution. So the problem provides you the differential equation and the solution. We are going to show that the solution satisfies the given differential equation. For the left-hand side of the differential equation is 2y prime plus y. The solution is in the form of y equals e to the negative x over 2. We just put on the side what is y prime, find the derivative, and we get e to the negative x over 2 multiplied by negative 1 over 2, which from applying the chain rule, or we have negative 1/2 e to the negative x over 2. And bring y and y prime into the left-hand side terms. We have 2 times negative 1 over 2 e to the negative x over 2 plus y, which is e to the negative x over 2. Simplifying, we have negative e to the negative x over 2 plus e to the negative x over 2. Both of them cancel to be 0, which is the same as the right-hand side. So we are done verifying. Next part, given an interval I of definition. Basically, you are going to find the domain of the solution function. Which we understood, which we know that the solution will be defined within the given interval. For this one, y equals e to the negative x over 2, we know that exponential function is always defined on the real number set. Therefore, the interval I of definition is the set of all real numbers, or negative infinity to positive infinity. Next problem. The differential equation is in the form of y double prime minus 2y prime plus y equals 0. And the solution is y equals x times e to the power x. To verify, we need y prime and y double prime. For this case, y equals x times e to the power x. Y prime can be found by applying the product rule and repeating similar process for y double prime. And then verify the differential equation. The left-hand side, y double prime minus 2y prime plus y equals, we replace y double prime with x e to the x plus 2e to the x. Replace y prime with x e to the x plus e to the x. Replace y with the x e to the x and then simplify. So x e to the x and x to the x times e to the x cancel with negative 2x e to the x and 2e to the x minus 2e to the x, that comes to 0, which is the same as the right hand side. Check. For the solution y equals x e to the x, the interval of definition is I equals the set of all real number, or from negative infinity to positive infinity, because x times e to the power x is defined in the set of all real numbers.